How's it going, everybody? And welcome back to our NSX-T series. In this video, we're going to be taking a look at our next topic, which is going to be overlay network segments and how we can leverage overlay network segments to provide connectivity to the between ESXi hosts using Geneve encapsulation. When you migrate to a overlay routing design or an overlay segment design, you are effectively moving the design to be strictly software-defined networking, where you're going to be deploying segments via the overlay connectivity. And when you want to do any routing in between segments, or if you want to route outside of the ESXi environment, you're going to be leveraging the edge nodes that are going to be deployed on edge ESXi 5 and 6 that will eventually connect up to CSR 1 and 2. So let's go ahead and take a look, a little bit of a deeper dive into how the connectivity is going to come into play, just so everybody's on the same page here. So what's going to end up happening is we have our NVDS deployed per host, and we have a couple of NICs, 6 and 7 mapped to each NVDS. What's going to end up happening is we're going to have communication going back and forth over the overlay segments when we get those deployed. The overlay segments themselves are actually pretty easy to deploy. It's just a couple of commands, just like the VLAN back segment. So let me go ahead and pull this out real quick. What you're going to get when we do this is you'll notice that we have the two dash lines, one here and one there, right? Well, what's actually going to happen is you're going to have there's going to be 2 TEP IPs per host, and that's going to allow load balancing. And the reason why there's 2 TEP IPs is because there's 2 uplinks. For every uplink that you apply to your NVDS, when you deploy an IP pool for overlay communication, that's where the connectivity is going to come into play. You're going to assign a TEP IP per uplink. Now, when you do your connectivity, you're only going to actually have one tunnel per peer that you're connecting to. That's all you're going to get. So it's one tunnel, and then you will source the IP address connectivity from one IP. And in the event that there's a problem, traffic will fail over, even though you're load balancing. So the load balancing piece is going to kick into play no matter what. You're going to be able to load balance over both uplinks. But from an IP perspective, you're only going to be sourcing from a single IP. So because the TEP itself is a logical instance, but you're going to be leveraging both uplinks for communication to all the other hosts. That's why I drew 2 dash lines or 2 dotted lines from every host to every other host. Now, I didn't do it fully to every host because that would have just gotten really, really dirty on the diagram, but I wanted to at least highlight to you how all that communication is going to come along. Now, once we do that, we're going to end up having this red dashed line here that I'm drawing across all the hosts. That will be sitting on all the hosts. And that's going to allow me to get the connectivity up and running where it needs to be. So once I have that process in place, everything else will fall in. And what will end up happening is, let me go ahead and pull my pen tool out real quick. What will end up happening is you're going to have communication going back and forth. And let me go ahead and clear the screen off real quick. What you'll have is any communication between the hosts on an overlay segment will be sent and received via the TEP. So that'll be the outer IP header. So from an encapsulation perspective, you're going to have the outer IP header. Inside of that, you're going to have the inner IP header. So outer and inner. I'm simplifying this, but so the outer IP header is going to be your TEP IP. And in your inner IP header is going to be whatever the IP address of the VM. So we're going to say VM IP. Now, when that happens, the TEP IP is also going to have a MAC. So inside of the 172.31.170 network /24, we're going to get a few MAC addresses that are going to be learned and some IP addresses, the ARP entries for the TEP IPs. When we do that, we're going to have encapsulation that is sent back and forth. the physical environment is only going to see the TEP IPs and the MAC addresses. So the TEP IP and MAC will be learned in their ARP tables. The physical network won't have any visibility at all of any of the VMIP or MAC info because it's going to be encapsulated inside of Geneve. And what's going to end up happening is when you go and attach any VM VNIX to a overlay segment, the overlay segment is going to learn all that information. It's going to be passing that information back and forth to NSX Manager to update all of its tables. That information will be propagated down to your other hosts. And what will eventually end up happening is you're going to have an IP binding. So what IP address do I need to an IP and MAC binding that's going to be tied to a VTEP. And that TEP IP is going to be where your pointer is. I need to get to a specific IP and a specific MAC address inside of my same subnet. What next hop IP address do I need to point to in order to reach that? So if I've got VM1 here and I've got VM2 here and they need to be able to talk to each other, I'm going to basically say I want you to point out towards host 2 in order to reach VM2, and from ESXi2 in order to reach VM1, point to ESXi1. And then the traffic will go back and forth through the network like that. And that's essentially the traffic flow that you're going to see. And we'll pull up the ESXi host and we'll take a look at the distributed router and all the routing that comes into play with that, because it does get kind of in the weeds and there's some actual communication that we're going to have to go learn and stuff like that. So it's pretty straightforward once you get into it a little bit. And I'm going to log into the hosts and look at the NSX CLI and how that all comes together. So without any further ado, let's go ahead and take a look at our connectivity here. I'm going to go ahead and pull this guy up. So I've already done a little bit of pre-work already. I went ahead and for the IP address pool, this is the first thing that you need to do. It's already been created. I'm just going to go ahead and expand it on it. So what's going to end up happening is you're going to need a subnet. So the subnet name, in this case here, is going to be transport node pool for assigning IP addresses to the transport nodes, which is going to be in the range of 172.31.170.11 through 30. So more than enough IP addresses for what I need. Once that's done, the other thing that we have to go do is on every host that is going to be attached to the overlay segment, we have to make sure that there's a transport zone for that. So we're going to expand fabric and we're going to go to transport zones. And we should have a overlay transport zone defined, or an overlay TZ, and we do. So and what we're going to do then is we're going to go to profiles, and on the transport node profile, we're going to look, and right here it says overlay TZ. If I wanted to edit that and modify the transport zones, I can come down here to edit, and then scroll down to where the transport zones are, and I can come in here and advertise or add on whatever transport zone I want to. So if you have multiple transport zones, and remember when I said that the transport zone is a boundary, you can control which VMs will be able to talk to each other based off of the segment that they're attached to, as long as and how far the stretch is. I do have a couple of customers that we kind of mix and match transport zones so that we can provide connectivity between a couple of different layers, and as long as the communication has been added correctly to the individual transport zones, you're in good shape. Normally you're not going to do that. You can, but you're normally not going to. Typically the only time that I'm going to sit there and split up transport zones or try to get fancy with my transport zone assignment to ESXi host mappings is if there's a specific reason I need to. Normally I'm going to leverage distributed firewall to handle those type of things. So as long as the TZ is good to go, you're okay. So I'm going to go ahead and click on cancel that. Now I'm going to go over here to nodes. So any of the hosts in cluster 1 or in cluster 2, cluster 2, the modification here, if we come over here and we go to actions and we manage transport zones, if you have a single host, you're going to manage it via this. In this case here, I've made sure that overlay TZ is attached to a single host. Where on the transport node profile that's mapped to the cluster, I had to map the variables, so the additional TZ mapping to the transport node profile, so that it would automatically get mapped to the individual hosts. Now, you'll notice here on the right hand side is I have TEP IP addresses. I've got 172.31, 170.13, 11, 12, 14, 16, 13, 15, 17, 18. Now, those are the TEP IP addresses, and like I said just a minute ago, you're going to get 2 TEPs because we have 2 uplinks. If you only had a single uplink per ESXi transport node, you'd only have 1 IP address. So that's there, and you'll notice that there's no tunnels. You might say, well, how come there's no tunnels? The reason why there's no tunnels is, unlike NSX-V, where once you created the overlay segment, the connectivity was automatically in place. NSX-T will tear down and spin up TEP tunnels based off of the needs of the network. So if you have hosts that have VMs running on them that have their network adapter in an overlay transport zone, or attached to the overlay segment, that there will be a tunnel that's needed to be spun up there. Okay, well, how do you know if a tunnel is needed on a particular host? Well, the answer to that is easy. You've already got the NSX VIBs installed on the host. So the moment you go and map a network adapter on a VM to an overlay segment that's pushed by NSX, the moment that VM VNIC is mapped to the overlay segment, information is sent from the local control plane to the central control plane, the manager, to update him and say, hey, I've got a VM attached to it. Therefore, they're communicating back and forth, and a tunnel is needed to this new host in order to allow overlay segment communication. And that's where that comes into play. When I go and I map, and the way to do this, when I go to map VM VNICs to the overlay segment, here that I'm going to make in just a second, you're going to see the tunnels all come up, and you're going to have several tunnels going back and forth. Let me go ahead and get out of here. We go back over here to networking and segments. I'm going to say add segment. And the name of this guy is going to be, let me just make sure I got the right name. So it's going to be NSX Linux overlay. So NSX Linux overlay. Something very simple like that. We're not connecting to a gateway. And the transport zone is going to be overlay. And that's literally all I have to do. This is going to be a layer 2 communication only. I'm going to click on save. Click no. And now if I go back over here, I'm going to see an overlay segment show up here in just a moment. And there it is. Overlay showed up. So now what I get to go do is on all these VMs. So I've got several VMs going back and forth. I'm going to take all the Linux VMs and I'm going to map them to the overlay segment. Now I'm doing that because I want to show you that the tunnels will all come up and we'll have communication. However, every one of the connections that I'm going to have, all the Linux boxes, have DHCP assigned IP addresses. So I'm going to have to, once I get that configuration in place, I'm going to have to change the IP addressing on them. I'll pause the video, statically assign it, and it'll be that much easier for you guys to work with. So let's go back over here to this guy. I'm going to go and take everything that's on comp Linux, and I'm going to right click here and say migrate VMs to another network. I'm going to browse. I'm going to choose NSX Linux overlay. Click on OK. Click next. And I'm going to choose to move all the VMs. So right now it's polling the network to see what's all available. Okay, so I've got Linux 2, 3, 4, 5, and 6. Perfect. Click on that. Click next. And then finish. It'll take a minute for that to happen. So I'm going to go over to overlay. And we should have VMs. We have 5 of them. Perfect. Now if I come back over here and I do a refresh, eventually this port count will jump to 5. But in the meantime, we go over here to system, nodes, and we're going to go ahead and refresh this. Right now nothing is showing up because we haven't given it enough time to synchronize that information. So I'm going to pause until all that is done. Okay, so it took several minutes for the ports to show up in here, so it probably just a syncing issue, but we have VMs 2 through 6 are now on the overlay segment. So now I'm going to go back over here to System. I'm going to click on Nodes, and it's been 3 minutes. I'm going to click on Refresh, and we're going to see a bunch of tunnels. These tunnels themselves, if we look at it, we have 17, 18, 13, 15, 14, 16, 11, 12. So I'm going to click right on the 3, and that's going to bring up another dialog box that we're going to be able to interact with. And what we're going to see is we have the VM kernel, the physical NICs, all that good stuff is up and running. Then we're going to see we are, source IP is 18. We're connected to 11, 14, and 15, right? So, and we can tell who it is. We can see it's 1, 2, and 3. And we can see the tunnel name is Geneve, and whatever the variable is. Let me go ahead and scoot this over just a little bit. We can see all that detail right there. So if I close this out, I'm sourcing from 11 on host 2, right? And I'm going to whatever IP address I need to reach. Now, because I have that in play, I now have this going on, right? I have this communication going on back and forth. So I'm using both uplinks for load balancing, because that's how the uplink profile is defined, but I'm only sourcing from one IP address. I don't load balance from both. Now, I don't know exactly how. I'd have to go back and look at my notes to see exactly how load balance source does it, but if it's anything like the traditional LACP port channeling load balancing mechanism, it does per packet, right? It's going to go and, or is it, no, I'm sorry, it's per flow. So if I have multiple connections opening up with the source IP, destination IP, source port, destination port, and if that stuff starts changing, that's going to change how the underlying queuing of the ports is going to send the traffic out to the network, because it'll be a different hash. So that's basically where that's going to come into play. Now what I'm going to go do is I'm going to pause the video. I'm going to go in, I'm going to update the IP addressing so that we can ping back and forth. Because if I was to jump out of here and minimize this and go back over to vCenter and look at my IP addressing for Linux 2, notice my IP address is gone. Because there's no, we essentially went through and we took the NIC out and moved it to a different network, right? So the IP address went away. DHCP hasn't been set up on these overlay segments yet. So I'm gonna have to go statically configure the 5 Linux NICs that need to get updated. So I'm gonna take a couple minutes, gonna go knock that out, and then I'll bring you guys back in and we'll do some ping tests. The one thing I get to go do is I'm actually gonna be able to go and download Wireshark, and I'm gonna be able to do some verification tests to prove to you that it's actually Geneve encapsulated. Not that I think you would think me as a liar, but I like to be as transparent as I can, and this is one of the ways that I like to demo it. So give me a second here and I will get everything taken care of. Okay, so I was able to download Wireshark, and I simply put in a filter in for ICMP, and what I'm doing here is I've got Linux 2, right, and I've got, let me go ahead and scoot this over just a touch, Linux 2, and I've got Linux 4 sitting right here, and the IP addresses match up, and we'll make sure they line up 100.12, and we have 100.14. So if I ping 12, I can see communication between those two working, right? Now I'm going to Control C that, and if I click on any one of these entries and I scoot this up just a little bit, where the encapsulation started, we have the frame that goes on the wire, then we have, this is layer 1, then we have layer 2, the MAC addresses, they're both VMware. Now this is the outer IP address, or I'm sorry, this is the inner IP. We have the inner IP, this is the inner layer 2 header. So if you look at it from an encapsulation perspective, let me go ahead and draw this out real quick. So we have from left to right, with the directionality being this direction, we have, this is the inner IP, this is the actual wire, and then this over here would be the application, right? It's ping packet, right? So what we're going to be doing from left to right is we have layer 2 header. So this is the outer layer 2 header. Then we have outer IP header. Then we have, which is these two, right? And then we have UDP. So this would be layer 4, right? So this is outer L4. And we know that because we have UDP and a port number. Okay, so this is UDP encapsulation. So actually, let me clean this up a little bit and make that a 4. Then we have our, I'll consider it the outer header again, and this will be the Geneve encapsulation. And then we're going to have our inner header. Our inner header, we're going to have our layer 2 header. Our inner header, we're going to have L3 information, and then we're going to have the inner header, we're going to have basically the rest of it, we're going to have ICMP. So that's going to be the encapsulation. So if you split it down the middle, this side right here is all of this right here, and all of this right here is down here. Now, why is that important to know? Because we're dealing with encapsulation. Anytime you are sending traffic over some sort of IP-enabled network and it's encapsulated inside of whatever it is, whether it's Geneve, VXLAN, NVGRE, so on and so forth, GRE tunnel, DMBP, and IBSec, they're all overlays. So that's where this comes into play from an operational perspective. So the physical network is going to see this side, right? It's only going to see the layer 2 MAC and the IP address of the VTEP and all that type of stuff. It's going to see the encapsulation. This is all virtual right here. On the left side of the vertical bar, this is all virtual. It's whatever the MAC addresses of the VM, the IP address of the VM, so on and so forth. So that's where you need to understand the operational piece to it and how that comes into play. I know it can be a little confusing when you look at this, but if you know the IP addressing scheme, it makes it that much easier, which is why I've laid out the addressing scheme the way that I have. So with that being said, that's basically what I wanted to cover in this portion of the video and lay out that and how it comes into play, because it's, once you understand how this process comes into play and how it works, it makes it so much easier to understand the rest of it. So we'll be able to take a look at inter-VNI routing and take a look at gateways, and I'll set up another segment for Windows devices, and we'll go that way. I'm going to continue keeping at least a couple VMs on the VLAN back segment so we can test what that looks like later on down the road. But for right now, I'm going to, between now and the next video, I'm going to deploy a couple Windows VMs so we can do communication back and forth between those, in addition to doing the connectivity between them. So we'll take a look at, I'll deploy another segment, I'll map the Windows VMs to it, and then I'll put a gateway in. We'll be able to do layer 3 communications. So with that being said, ladies and gentlemen, thanks so much for stopping by and hanging out with me. If you have any questions, please leave it in the comment section below. Please like, share, and subscribe, and I'll catch all of you in the next video.